Okay, pre-calc. Here we go. We're moving on to the next section. This section is regression. So what I want you guys to do today is I want you guys to get out your graphing calculators, and that's about it. Okay, you guys can take notes later. I want you guys to stay 100% focused on the calculator today because everything we do is going to be based on the calculator. So there really are no notes today. What I'm going to do is I'm going to go to a PowerPoint today, and I'm going to show you guys exactly what we're going to be doing based upon that. So today, what we're talking about is going to be Chapter 1-7, Linear Models and Scatter Plots. So as I go through this PowerPoint, I want you guys to be thinking about all of this, what the scatter plots are, how linear regression is going to be used, and how our calculator is a huge, huge help in what we're about to do. So the first thing we need to talk about is a scatter plot. A scatter plot represents data graphically using points plotted on a rectangular coordinate system. So pretty much you have your coordinate plane, and what you're doing is you're plotting the points x and y. 1, -4. 1, -4 is going to put us lovely little down here. 2, -2 puts us here. 3, -1 puts us here. 4, 0, and so on and so forth. This is a scatter plot, and what we're going to do is we're going to actually be doing this on our graphing calculator so that you guys can actually see how all this works out there. But again, you guys have been doing scatter plots for a while now, so this is not anything big news to you. Okay, so now next we're going to talk about putting this on our calculator. So an example, the average salary S in millions of dollars for professional baseball players from 1996 through 2002 is shown in the table. Let T = 6 represent the year 1996. Draw the scatter plot. The first thing I want to draw your attention to is the fact that this says let T represent the year 1996. Well, why in the world are we allowing T to = 6 be the year 1996? Well, if you look at this, do you see that I have a quadrant as my lovely quadrant 1 as my lovely little scatter plot area? In other words, our whole point is to try to represent our data as close to the origin as possible. The origin is the point 0, 0. So what we want to do is we want to scale everything down, because how silly would it be if we were to actually take 1996 and go clear away from the origin and then not be able to see our y-axis and what it represents versus our x-axis and what it represents. So what we want to do is we want to scale everything down and get it real close and tight to the x and y-axis of the origin 0, 0. So 1996 represents the number 6, and then what is going to be 2000? Well, 2000 is going to be 6 is 96, 7 is 97, 8 is 98, 9 is 99, 10 will represent 2000. So what's 20 going to represent? Well, 10 represents 2000, and 20 is going to represent 2010, and so forth. So you need to think about that for whenever you're doing your little predictions later on in the future. So what I want you guys to do is I want you to pull up your graphing calculator. And as we pull up our graphing calculator, I'm going to do the same thing with you over here. What I want you to do is I want you to grab a new document. So this is on recording, so if you guys get behind, I want you to hit pause and rewind and get into the place that you need to be with me whenever you're doing this. So with that said, I want you to go to a new document, and what I want you to do is we need to enter in data, don't we? Because this right here is a lovely little scatter plot. We have to get this data that's in this XY table into our calculator. So does anybody know what I want to do? Do I want to calculate? Do I want to graph, geometry, lists and spreadsheets, data and statistics, notes, or veneer data quest? Well, what we want to do is we want to enter in data in a table. Well, a table represents a spreadsheet, so we want to do a spreadsheet. Now, just like in Excel, what you're going to notice, you have column A and column B, C, and D, and then we have rows, our row 1, row 2, row 3. Well, this shaded region here, these shaded regions is going to be the area that you're going to put your lovely little formulas into. Okay? So the formulas that we're going to put in here, we're not going to put in here for a little bit, but I want to make sure that you actually see that that's a formula region. So for today, you're not going to put anything in there right now. Letter A, column A, what I want you to do is I want you to label that to be what we've labeled this over here. Well, in column A, I have years. So what we're going to do is we're going to label this to be years. So I'm going to type in years here and hit enter. Notice that that's bolded in the gray area, that's bolded. Now, obviously, you guys are going to be typing this in by hand. I'm actually typing on keyboard, so things are going to go a little faster for me. So please, by all means, please pause me. Okay? Now I'm going to arrow over here to column B. And what do you think I want to label that to be? I want to label that to be salary. So I'm going to type salary in here. Okay? Now I want to be in row 1, column A. And I'm going to start entering in the data. The data that they're giving me is the year 1996. Am I going to type in 1996? Well, according to what we talked about here, it said let t equals 6 represent the year 1996. So I'm going to go over here. I'm going to say 6 is 1996, 7, 97, 8, 9, 10 is 2000, 11 is 2001, and 12 is 2002. So I've entered my data 6 through 12, and those are my years. Now, the shortcut key, are we paying attention here? The shortcut key to go to the top of your data is going to be Control 7. That's going to take me to the top of my data without scrolling all the way up. I'm going to arrow to the right. I'm going to be in column B, row 1. And now I'm going to enter in the data, the salaries of these lovely little baseball players. So that salary is going to be 1.1, 1.3, enter, 1.4, enter, 1.6, enter, 1.8, enter, 2.1, enter, and 2.3, enter. So now what I've done is I've essentially entered in my data. Now, our goal is to make this over here, like our lovely little PowerPoint presentation has over here. We want those dots. So now we're going to add a new page. So if I'm going to add a new page, how do I go about doing that? I'm going to hit Control Doc to add a new page. And what do you suppose I want to do? I want to graph, you're right. However, I'm going to show you 2 different methods to graph this. The first method is going to be using data and statistics, because that's exactly what we're doing, is we're doing data. So I'm going to take and add a data page. And do you see this looks like a nice Velcro wall where I've taken a whole bunch of Velcro ping pong balls and I've thrown up against the wall. That's what it looks like. What we need to do is we need to rearrange these balls into an organized fashion. So the way we're going to do that is, do you see that we have click to add a variable, and down here click to add a variable. These 2 places represent our x and our y axis. So what we're going to do is we're going to click down here on our x axis, and when we click on that, it comes up with year and salary. Now, what do we want our domain, which is our x axis, to represent? Well, if we come back over here, what was our domain down here? Our domain was our year. So we need to come back over here, we need to select year. Watch, isn't that a beautiful thing? Do you see that? It just magically rearranged our data. Our balls just moved right across there, according to the years. But my question to you is where did my y-axis go? Well, move your mouse all the way to the left until you get in a rectangular box. When you get to that rectangular box with crosshairs there, click on it, and what do you think we want that to be? Well, if we go back to our scatter plot on our PowerPoint, that was salary. So we're going to click on salary. Isn't that gorgeous? Now, come on, how many of you think that's really cool? I know a couple of you think that's really cool. This is an amazing concept here. What this allows you to do is it allows you to see 100% your data right there in your nice viewing area without having to adjust anything whatsoever. Beautiful, love it, don't have any problem with it. Now, what this area allows us to do is it allows us to do a lot of information here. I can do a regression model if I want to here. So what we're going to do is we're going to stay in here. And I want to find a line that represents the best fit for all of this information. Do you see all those data points there? I want you to physically draw a line between those data points. And you could actually, if you wanted to, you could draw, and I am going to show you on here, that I could draw a line through here. Maybe it'll come up. Okay, it won't. So sorry. Don't know why, but it won't. So with that said, maybe I can get my floating tools here. Nope, it won't come up. Sorry. But just imagine there's a line in there. So if you imagine that there's a line in there, what I want you to do is I want you to calculate how could we come up with a line that would go through all of those points that could give us prediction later on into the future about what the salaries would be of these baseball players in, let's say, 2020. Okay? If conditions would be exactly the same as what they are currently, what would be a prediction into the future of what those baseball players would make in the year 2020? Well, the only way we can do that is by actually getting a line in the form of y equals mx plus b. So how do I go about doing that? Well, what I want you to do is I want you to hit menu. And in menu, what do you think we want to do? We want to plot type, plot properties, actions, or analyze. Well, in doubt, go ahead and look at those. If you look in there, you can see all kinds of fun little things, okay? And I want you to go down to analyze, because what we want to do is we actually want to add a movable line. If we add a movable line, what this allows you to do is it puts a line in there. And do you see how I can move my cursor? I can estimate what I think is going to be a movable line, what I think is going to work. And I just picked this up and moved it. And again, for you guys to move things, you're going to have to hit Control, click whenever you get on things. You're going to have to hit Control, click. So I undid that, so I'm going to show you guys again, just so that you guys can see it. So I'm going to add a movable line. And mine says M2 because I just already added one previously. So here's my equation. Okay, that's the one I'm going to choose. That is my movable line. That is what I could possibly think. I'm hitting as many of the points as I possibly can, and that's what I think the slope is going to be. So I'm going to say that my rate of change, which is going to be 0.185, is going to be the rate at which every year the player's income is going to increase. It's going to increase by 0.185. Now, what we want to do is we want to find out if that's actually a true prediction. So what we're going to do is we're going to go to Menu, we're going to go to Analyze, and this time we're going to do Regression, because what we want to do is we want to do a regression model so that we can see into the future about what's going to happen. So the way we're going to do this is we're going to do level little mx plus b, because that's what this thing looks like. It looks like mx plus b. Now my slope was 0.185. That was pretty darn close to what this regression model is right there at 0.2x. That's pretty good. That's not too bad. You can clearly see I'm a little bit off. There's that equation. Here's my regression model. Do you see the difference between them? But I actually have to click on that. Isn't that annoying? I have to click on that. This is the only place that I can actually add a movable line. I can compare what I think it was to what the actual equation is, which is pretty cool. Okay? Now, before I go on, I want to go ahead and I want to show you the next slide here, and I want to talk about a couple other things. Now, this talks about the 83. We're not doing the 83, but for those of you who are borrowing an 83, you might want to go through here and you might want to look at that. But I want to draw your attention to slide 5. In slide 5, it says in a collection of ordered pairs x and y, if y tends to increase as x increases, the collection has a positive correlation. This right here, all of them have a positive slope. All the points are clustered together, at which point, since they're clustered together going in an uphill fashion, it's going to have a positive correlation. The next one, all of the points are going in a downhill fashion, so therefore those are going to have a negative correlation. And then these ones, they're just plastered all over the place, so therefore they have absolutely no correlation whatsoever. So this is going to be one of those where you really can't find a good regression model. So you can't really do a good prediction because there's too many things that affect it that make it be thrown off later on in the future. So what you need to understand is positive, negative, and no correlation. So those are 3 things I want you to remember. Okay, we're going to go back to this in a moment. The next thing is we're talking about finding the line of best fit, and I talked about a movable line. A movable line is something I call a trend line. So some of the things I've talked about is a movable line. This is also known as a trend line in mathematics. A trend line is used or found by using 2 points of the data. What you're doing is you're finding the slope, and then you are going to find the equation of the line using the slope and a point. Now, obviously, this is not at all going to be the best method to use because obviously you are eyeballing and you are judging this on just 2 points. Okay? But the next one that you need to talk about is going to be a regression model. A regression model is calculated using all the points, okay? And what the calculator does is it takes all the points into account, and what we're going to be using is going to be using the R value The R value is the correlation coefficient of the data, gives the measure of how well the model fits the data. So the closer the R value is to the absolute value of R is closer to 1, the better the points can be described on the line. So if you're looking at this one, we have a positive 0.99 as my R value, 0.99. That is a very strong correlation. And if what you can see here is see all of the points that this thing is hitting. See all the points this thing is hitting here? It's all really close to it. Okay? I tried to zoom in so you could see it a little bit better, but I think I'm getting too far off, so let me come over here a little bit. Okay, over here, do you see all the points that that's landing on? All the points that those landing on, that is a very, very strong correlation because it's a strong correlation of 0.99. Now, if I come over here to the negative correlation, this one is negative 0.093. The negative indicates that all the points are going downhill. And again, it is 0.93. But notice it's not touching all of these ones right here on this hook up here and the hook down here. But it still has a pretty good value. That's close to 1. So, you know, that's not a bad. So that's a strong negative. And then we have one over here. That's just a negative correlation. That's not very helpful. Hold that thought a minute. We have a weak correlation on this one of 0.66. And notice there's barely any dots being touched. So this is a negative correlation. This is a strong correlation. This is a negative correlation. And this is a weak correlation. You can see that the strong correlation, they're all on the line. The weak correlation is none of them are on the line, just maybe 1 or 2. And then the negative correlation is going to be, you know what, there's several off the line, so therefore I'm going to say that that's going to be just a negative. Not a strong, but a negative, because they're not all touching the line. So the R value is what you really need to look at. Now what I want to draw your attention to is whenever I use this method right here, did I ever get, that's my movable, did I get an R value here? There's not an R value here, which is one reason why I don't like to use this method to graph up the scatter plot. So what we need to do is we need to figure out another method that I can use to graph this. So what we're going to do is we're going to add a new page. And this time, I want you to go with your gut instinct. Your gut instinct, whenever I said I wanted you to graph a scatter plot, was to use the Add Graphs page. So we're going to add a graph. However, do you see that this F1 right here, that F1 indicates function notation. Function notation means it's your f of x, g of x, h of x things. It's graphing your parent functions, x, x squared, x cubed. It does not allow you to graph scatter plots. So what we need to do is we need to hit Menu. And do you see where it says Graph Type? Click on Graph Type, and what do you think we want to graph? Obviously 4. We want to graph a scatter plot. So if we're going to graph a scatter plot, immediately what it says is S1. S1 indicates scatter plot 1. S2 would indicate scatter plot 2, and S10 would indicate scatter plot 10. Now what do you think we want to do in the X? The X is going to be, what is your domain? Well, what did we want our domain to be over here in this lovely little slide 2? Sorry, 3. Our domain here was going to be our year. So we're going to come back over here and we're going to type in year. Did you see how it bolded? Do you see how it went from REA just like italicized to bolded and not italicized? That means it's pulling the information from the problem that we were currently in. Now it'll only pull from the problem that you're in. So I'm in 1.1 is my data. 1.2 is going to be my data and statistics, and then 1.3 is my graph. It will only pull from the information that you have. So I type year, and that's going to pull it from problem 1 data. Now, what do I want my Y values to be? Well, my Y values, my range in this problem was going to be salary. So I want you to type in salary. Again, spelling it correctly. Now, there's one thing I did not discuss with you, and I want to go back and make sure that you understand this because maybe some of you already had this issue. So what I want you to do is I want you to go back to 1.1. 1.1, it is very, 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 very important that you check your dimensions. In other words, do you have more X values than what you have Y values? Because if you do, the calculator is going to say dimension mismatch. and that's going to cause you all kinds of headaches. So what I need you to always do is make sure you check your data and make sure that you have the same amount of y values and x values every time. So I'm going to go back to my lovely little 1.3, and I'm going to type in my year and my salary again, and I'm going to hit enter. Do you see that I only see a little bit of it? Well, the reason why I only see a little bit of it, I don't have this nice view that I have over here in this PowerPoint. I want to see that view. So I'm going to come back over here, and I'm going to hit Menu, Window Zoom, and what do you think I want to zoom to? Well, I want to zoom to see my data. So whenever I hit Data, it automatically zooms it so that I can just see my data. And notice that I have year, comma, salary. In other words, what this is telling you is that your year is your x coordinate, your y coordinates are your salaries. And that is coming from which page? From page 1.1. That is where it's allowing us to see our data. So now we have our graph of our scatter plot. Now I want my regression. So I'm going to add a new page. And our new page is where we're going to calculate our regression model. So where do you think we would do to calculate our regression model? Well, we want a calculator page because we are going to calculate the regression. So after we get our calculator page, we're going to hit Menu. And in Menu, what do you think we want to do in here? Well, what we're going to do is actually statistics, because statistics is where regression comes from. So once we're in statistics, then we want to go into stat calculations. Stat calculations. And within stat calculations, we have a whole list of information here. Now, what do you think we want to do? Well, our data clearly takes a linear approach to it, so therefore we want to take linear regression, which is going to be 3. But when we get here, what we have is a table we have to fill out. And it says, well, what do you want to use for your X list? Well, our X list is just another name for domain. So what we're going to do is we're going to right-click down, and we have a whole bunch of these. We just want to select year. We don't care about anything else. We want the year. Tab, and then arrow down. Sorry. What do you want for your Y list? Well, our Y list would represent our range, and that's going to be our salary. And then it says, well, where do you want me to store this regression model into? Well, this is a beautiful, beautiful thing. The Nspire is a beautiful tool for us because it no longer makes you copy and paste things. It automatically says, well, I can just go ahead and save that for you. And I'm going to save that in the regression model in the function F1. So we're going to store that in F1, and then the rest of this, just tab all the way down. You don't need any of that, and hit OK. So just to make sure your screen looks like mine, your X list is going to be your domain, which is your year. Your Y list is going to be your salary, and you want it to store in the function F1. And hit OK. Now, this is beautiful because what it tells you is it gives you a lovely little mx plus b. It tells you that m is 0.2. Now, what did we talk about m to be? M was going to be the change, the rate of change in which our player's salary is changing from year to year. So our player's salary is changing 0.2 every year. Whereas what's the b represent? Our b represents our y-intercept. So our y-intercept is going to be at negative 0.14. Our r value, we don't want r squared, we want r. Our r value is 0.99. So if our r value is 0.99, what can you tell me about this? Well, if we go back to our slide over here, if our r value is close to 1, that means that it is a very, very good model for the data that we have, that this will be very good at predicting. And since it is 0.99, that gives us the first example. We know it's a very strong positive correlation. So I know that since this thing is a very strong positive correlation, that's going to be great. It's going to allow me to do a lot of prediction later on in the future. So I'm going to go back to my graphs page. My graph page is on 1.3. So I'm going to go back to 1.3, and what I want to do is I want to see my regression model graphed with my data. Okay, my scatter plot's already graphed. I want to see how my regression model hits those points that I have graphed on my scatter plot. So how do I do this? If I hit tab, that's going to give me my graph type. Now, what graph type am I currently on? The graph type that I'm currently on is going to be my scatter plot graph. So what I need to do is, do I want to graph another scatter plot, or do I want to graph a function? Well, I want to graph a function. So I'm going to hit escape. I don't want added there, because what I want to do is I want to go to menu, and I need to go to graph type. And the graph type that I want to graph is going to be a function. Because remember, in 1.4, I stored my function into F1. Okay? So if I go back to 1.3, I see that this automatically brings me to F2. Well, why is it bringing me to F2 whenever I need to be in F1? Well, that's because there's already something in F1. So how do I get to F1? I simply arrow up. Do you see the difference between F2 and F1? F1 is bolded, where F2 is not. F1 is bolded, which means there's something in it. But guess what? I can't see it because I haven't activated that graph. So I'm going to hit enter. And whenever I hit enter, it activates that graph, and it will show you the lovely function. Now I'm going to put that label up there so that once I move it, it doesn't touch anything else. And what I want you to see is there's my equation. Now this would be the equation that you would actually write down on your paper whenever you're doing your homework. And you'd also would write down on your calculator page what your R value is, so that you can tell me if it has a strong positive, strong negative, weak, or just a positive or negative correlation. That way you can determine if this is going to be a good model or not. So I'm still on 1.3, and now I see that I have this lovely, lovely little graph, and I can see that it touches, or it's very close to, several of my dots. Now, as you can see, is it really touching any of them 100%? And again, I move that gear out of the way. You can see, don't move your line. Do you see how my cursor right there is a curved arrows? That means I'm moving my line. I don't want to move any of the points, and I don't want to move my graph. But I can see that the line is close to the scatter plots, but it's not physically touching it. So if I touch one of the points that is off of the line, see how it lights them up and you can see that? It is not physically touching any of those points, but it goes between every one of those points, and it will be the best model that you can use to predict into the future according to the data that was given to us. Okay, so now I have this information, and I'm going to go back over here, and let's say I wanted to do a prediction into the future. Okay, we have this, but let's say I want to know what's going to happen in the year 2005. Well, what we know is that 2000 is what year in our lovely little table here. Well, 1996 represents 6, so therefore 2000 is going to represent 10. So what's 2005 going to be? Well, 2005 corresponds to the year, or the number, 15 on our scale. Okay? So what I want to do is I want to evaluate this thing, the F1 function, at 15. I want to evaluate the F1 function at 15. Why do I want to evaluate F1 function at 15? Because I want to know what the average salary is going to be when we're in 2005. So if I go to menu, and then I do trace, and do graph trace, do you see down here at the bottom I have S1? What that indicates is that I am currently on my scatter plot. I don't want to be on my scatter plot, so I'm going to arrow down. Do you see when I arrow down, that's going to give me my function. When I arrow up, that gives me my scatter plot. When I arrow down, that gives me my function. Now that I'm on my function, I'm going to simply type in 15. And when I type in 15, I'm going to get an ordered pair down here in the right-hand corner of my graph, my picture, that it's going to be 2.86. Well, what does that mean? That means in the year 2005 that the average baseball player's salary is going to be $2.86 million. If I wanted to know what 2000, okay, so this means if I'm evaluating that, 2015, the average baseball salary is going to be 2.86. Understanding that the order pair, that was going to be 15, 2.86. So if that's 2015, can you tell me what 2012 is, which is the current year? Sorry, that would be 2005. in 2015. Well, 2012 is going to be what year? Well, if 2000 was going to be 10, then 2010 would be 20, so then 2012 would be year 22 on our scale. Okay? So now I want to evaluate at year 22. So I'm still traced. How do I know that I'm still traced? Because look, I can move this. Bam, look at that. That is so cool. I can move that. But I'm going to just simply hit 22 and hit enter. And that's going to be $4.26 million a year. Now, you tell me, is this actually going to be a true statement? Do you think in the year 2030 that they're going to be making billions of dollars by then? I sure hope not, because if so, we're all in the wrong job, most definitely. So eventually you're going to understand that this probably is not going to be the best model to do future predictions, like way off 50 years, 60 years, because it's going to be an astronomical number. But this will give you a good idea how to do a prediction and predict it in the future, which is a great thing. Okay? Now, what I want to bring your attention to is I actually have steps for this. Some of you are probably thinking, how am I going to remember to do all of this? Well, I have actually listed every single thing that you would need to do. Step 1, choose a new document, choose your list of spreadsheets, label them, enter your data, and I'm letting you go step by step on how to do this. Now, what I want to do, we're comparing original data to the regression model, is let's compare that. This is where I want to go to. So you don't have these copies today. We're going to do this Friday in class, but I did want to just introduce this to you a little bit. I don't have much time left. What we're going to actually do on Friday is I'm going to make you guys compare your models here. And maybe maybe we should stop right here, because I think we've talked a lot about that today. So what we're going to do is I'm going to stop you. I'm not going to leave you completely to yourself. You guys don't have any homework tonight, because we're going to do all of this tomorrow in class, because this video is 32 minutes long already. So what I want you guys to do is I want you guys to go ahead and answer your questions, or answer my question in the Edmodo assignment, and then you'll be done for tonight. Make sure you get your 1-6 worksheet done, and we'll talk about this all on Friday.